Module 5, problem number 8. To test the belief that sons are taller than their fathers, a student randomly selects 13 fathers who have adult male children. She records the height of both the father and son in inches and obtains the following data. Are sons taller than their fathers? Use alpha equals 0.1 level of significance. Note, a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. So right there, we know that some of the conditions are met. One thing I want to talk about before we dive into this problem is this is a father and son height problem. When we listen to this, are we looking at independent data or dependent data? Does it matter if a father is linked to their son specifically on the data set? The answer to that is yes. So if it's important that one observation from one data set is linked to a specific observation in the other data set, that means that we're looking at matched pairs data. So let's go ahead and dive into the problem. Which conditions must be met by the sample for this test? Select all that apply. The sampling method results in an independent sample. Well, we're not necessarily looking at independent samples because it's matched pairs data. They're dependent on one another. So that one we don't need to worry about. The sample size must be large. Yeah, no, but there's still some restrictions there. So let's talk a little bit more about the other options. The differences are normally distributed or the sample size is large. That gives us a little bit more information because if you have a smaller sample size but it's normally distributed, then you might be okay. The sample size is no more than 5% of the population. Remember, that's one of our, 0.5 times big N, which is your population size must be less than or equal to N, or excuse me, greater than or equal to N. So that means that the sample size must be no more than 5% of the population size. And then the sampling method results in a dependent sample. Again, we're dealing with matched pairs data. This is not independent data. So we have a dependent sample. Let's check all the, there we go, good job. All right, so now we have let DI, the differences, equal XI minus YI. So it means that we're looking at the difference between the observation, the mean in one set and the mean in the other set. So write the hypotheses for this test. Remember, what we're assuming here is that the father's data set, let's look at the data set real quick. Here we have the father's data set is going to be our XI. Our son's data set is going to be YI. That means that we want to see if the sons are taller than their fathers. So if we're looking at X minus Y, we want to know if that's less than 0. So right now we're going to say that the mean difference is equal to 0, right? That's our null hypothesis, always that the difference is equal to 0. But in this case, again, X minus Y, we want to know if the sons are taller. So if X minus Y and the sons are taller, that would mean that the difference is less than 0, right? That would mean that XI minus YI is less than 0, or X minus Y is less than 0. All right, let's go ahead and X that out. Let's check our answer. Well done. Calculate the test statistics. Let's open up that data set back again, and we're going to open this in StatCrunch. I'm going to close out so we can look at both at the same time. So here we have our height of the fathers and our height of the sons. So we're going to go to stat, t-stat, since we're looking at the mean. We're not going to go to two sample, that's for independent data. We're going to go to paired, that's for our matched pairs data. So the sample 1 is the height of the father, sample 2 is the height of the son. And again, we already found our hypotheses over here. So we're going to say less than 0, compute, great. There we have our really interesting number. I know you guys are gonna see this t-stat and think, what the heck? That's basically 0 when it looks like that. I know it looks very odd. So we're gonna go ahead and type in 0. See, it says e to the negative 15th. That's a really small number. I can't believe it actually came up with anything. Let's go ahead and check our answer. Well done. P-value, again, just a reminder, when you guys see that e to the negative 15, that's like saying times 10 to the negative 15th, I assume in this one. Where it's very close to 0. So if you see that negative exponent right there, go ahead and just put 0 if it's that high. And our p-value right here is 0.5. And if you ever have questions, if you see a weird number like that you don't understand, feel free to shoot me an email and I can help you out so you're not struggling with that. All right, so we were right for our test statistic and our p-value. So let's look over here for our conclusion. So our p-value is greater than alpha. When our p-value is greater than alpha, we do not reject the null hypothesis because the p-value is greater than the level of significance, which was 0.1. When we do not reject the null hypothesis, there is not sufficient evidence to conclude that the sons are taller, because again, that was our hypothesis that we were testing. That's our alternative. So we're saying there is not sufficient evidence to support the alternative. Okay? All right. That's how you do problem number 8. If you have any questions, let me know.